Right, and we get back off with hydrochloric acid, and that's going to our products. This type of reaction would not be expected. They would give you the products iron 2 chloride, so chlorines -1 plus 2, so I need 2 chlorines, plus hydrogen sulfide gas. So this one's a bit tricky. I guess you can think about hydrogen as +1 and sulfur as 2 minus. Reason why I know it's a bit tricky is because it is supposedly two non-metals, but technically it's ionic, so it's a borderline between the two, right? So I need two hydrogens to match the one sulfur. It's a gas, and sorry, that one's aqueous. Right, and we get rid of our working out. And after green, we got purple. Zinc metal placed in nickel solution. Zinc slowly. This looks like this displacement reaction. The only thing that you need to notice, it's like a two metal swap place. So you get a metal, say zinc here, reacts with iron nitrate, and they swap places. And the only thing you need to get out of that is the more reactive metal displaces the less reactive metal from solution. So to be a reactive metal means you easily lose your electrons, and to be a less reactive metal means you've got a better hold on the electrons. So essentially the electrons are going to go from the reactive metal to the unreactive metal, and they're going to swap places. One's going to go from a solid to aqueous. Okay. So zinc metal solid, we just write zinc by itself. Nickel 2 sulfate. I think we've encountered that already. That's I think that's got a color from memory. Green comes to mind. I can't be sure, but this would be like a green solution if you physically did this. And the zinc's more reactive than nickel. There's a list of it, by the way. You can just look up like the activity series of metals, and zinc would be higher than nickel, more reactive than nickel. And so it will react. It's obviously told us that it reacts anyway. And so you're going to get zinc sulfate aqueous, which doesn't have a color. So you would physically observe the green color to disappear. And then you'll start seeing deposits of nickel. Okay, literally, you get the solid form of nickel. And if it was like copper, then copper has a distinctive color, you'd actually see that distinctive color. So every time you're trying to learn about these, often what's demoed is ones that have particular colors. So nickel would be a good one for its green color. Copper's a great one for its blue color and its solid being different. Right, blue. Just staring at this reaction, doesn't look like it's any type of reaction. It's just learning how to do this. I haven't been worrying about balancing the last couple ones. Kind of skipped over that. I'm going to go back to green, I think. Get 2 there. I think that's all I needed. 2 hydrogens to that, and nothing needs to happen that, so I just gloss over the green. Anyway, coming back to this, carbon sulfide. I don't know why it gave you that. Anyway, 2 nonmetals, so you see the dye. This is a covalent compound. That would be a solid. I got the advantage. Oxygen gas goes to carbon dioxide gas and sulfur dioxide gas. Right, so obviously oxygens are out and sulfur is out. If I went and did a 2 straight there, it wouldn't solve much because I'd just have to come back to it. So I'm going to do a 2 there, which means I get 6 oxygens all up, which means that's my answer. After light blue, I get yellow. Iron hydroxide with heat, this looks like a decomposition reaction. I've got iron, and I need 3 hydroxides to match the iron. It's going to be in solid form, and it's going to decompose into iron 2. I'm swapping around the charges, so I'm putting the 2 of iron and the 2 of oxygen and 3 of iron on the other one. It's going to be a solid also. H2O, it's going to be a liquid at room temperature. And what am I going to do here? Looks like the first thing I'll do is a 2 there. So I've got 6 hydrogens on the left-hand side. So I assume I put a 3 there to make the 6. Remember, it's 2 times 3 on the left-hand side. And so oxygens, I got 4 in total, but I've got 6 there. So what am I going to do here? 2 ions, 3 hydrogens, 6 oxygens. Oh, I got 6 oxygens. 6 oxygens, it's all balanced. I'm just not very confident. Moving on. It looks like a decomposition reaction. Ammonium carbonate. Carbonate's 2-, ammonium's +1. So we're going to need 2 ammoniums. It's going to be in aqueous form. Could be in solid form. I'm going to stick with that rule that could be not in water. It's probably going to happen. If I'm heating it, it's probably going to not be in water. So I'm going to go solid. It would dissolve in water, by the way, because it's got ammonium. Ammonia gas is NH3. It's not ammonium, it's ammonia. Carbon dioxide and water, liquid. And ammonia, I'm going to definitely put a 2 there for the nitrogens. It's going to make my hydrogens are going to be 6, 8. There's 8 there. Carbon, that's all good. After pink, we have orange. Silver carbonate is heated and turns into silver metal, carbon dioxide, nitrogen. Okay, so silver is always +1, by the way. They'll start to get dropped. Silver carbonate, if it's carbonate's 2-, so I need 2 that. Carbonate CO3, we can make it solid if it's decomposing. Turns into silver metal, AgS, that'd be nice. Carbon dioxide and oxygen gas. Right, so I'm gonna have to put a 2. I might just leave that for now. It's gonna put a 2 there, but I feel like I'm gonna have to change that. So I got 4 and 3. Lowest common denominator to them is 12. So I'm gonna put a 4 there. This doesn't feel right at first, but I'll give it a go. So that makes 12. And I'm gonna have to put a 4 there for the carbons, which makes 8. And then that must be 2. All right, so just double check at 8, 4, 12, 12, 4, 4, 8, 8. Doesn't look right. I can halve everything. Why did I get there then? I go 2, 4, 2, 1. Why did I arrive at that in the first place? Because the lowest common denominator. Because I was thinking lowest common denominator, but I had things split over there. So what I got 6, 6. Okay, all right. Did it special because my maths isn't as strong, but I got there in the end. And it's always good to double check. Green. Okay, we got our first combustion. So combustion is when you have a fuel. The fuel will always contain carbon-hydrogen bonds. So this is actually an organic compound. And so you wouldn't be expected to name propane. Prop means 3 carbons. Ane means they're all single bonded to each other. And so if you drew that out, it'd be 3, boom, 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 1, 2, 3. The rest are hydrogens, and I drew a hydrogen all here. This is what it looks like. Anyway, propane is a gas as well, so I get that advantage. Gas. The first 4 are gases, and then pentane is a liquid. Oxygen, CO2 gas plus H2O liquid. All right. And what you do is you go balance the carbons first, hydrogen second, oxygen's last. So just go in sequential with combustion. So 4 there to balance the hydrogens, and then you go, okay, how many do I have on the right hand side? I've got 6 plus 4, I've got 10, put a 5 there, nice and easy, done. After green, we go purple. Pentane, this will be a liquid, I got that advantage. You wouldn't be expected to know that. Burns in oxygen. This is complete combustion, by the way, because you get carbon dioxide, liquid, right? 5 here for carbon, 6 here for hydrogen. That gives me 10, 16, 8. Okay, good. Not tricky at all. I'll pause there.